So this is a Dacia Duster key fob that somebody brought into our local repair cafe, and what he said was it's only working intermittently. Now I have had a look at this before because one of the buttons was actually broken off, and I managed to solder the button back on and it's been working fine for a few weeks. But now he said it's only working intermittently, so let's take it apart and we'll have a look, see if we can figure out what's wrong with it and hopefully repair it. So I think it comes apart just around about here. And I'll probably have to bring the microscope in on this one. So we can get this little board out. Right, let's bring the microscope in and we'll just have a look, see if we can see anything obvious. Now we did get a quote for a replacement off Dacia, and I think it was something like £250 plus VAT, which I thought, it's a bit extreme. Now there's usually two parts to one of these key fobs, or the key in general. You've normally got something like a RFID transmitter, which does the immobiliser part of it. Now I think this might be it here, or this might be a coil with a capacitor across it, which is like the RFID part, and the actual RFID data bit might be handled in this IC internally, because it is by NXP, and I know they do things like RFID. And the other part is the central locking, and from the same chip we've got this trace here which looks like an antenna, which then goes all the way around the board, comes to this point here, again goes around the outside of the board to this via, and then back through capacitor, and then back into the IC. So I think this is the transmitter part of the IC here, and this part round here is the RFID section for the immobiliser. Well, I can't see any dry joints or anything. And say the fault with it the last time was actually this button here, which had broken away from the circuit board, and I think one of the pads had lifted, so I've resoldered it. So I think the first thing I want to do is just check these buttons with the test meter just to see if they're both working. So let's put the meter into continuity mode. Well, that one's working. As I'm pressing it there, it's beeping. Let's try this one. Right, so I think that's the problem. Pressing the button here, and it isn't beeping. Let's just try. Right, so I think this button here needs to be replaced. Right, let's see if I've got some of those buttons. I'm not sure if these ones are the same. Let's have a look. Well, it's very similar. Or is it these ones? Let's have a look. I think it's these ones. Right, let's get the old one off then. I'm just going to add a bit of flux onto this. I'll just spin it around. Right, that's the old one off, and that's the pad that was missing. But it's not connected to anything, so that should be fine. Right, I'm just going to give these a bit of a clean off. So it looks like there's a position for another switch here, and another one. So it looks like this remote circuit board might actually do 4 different functions. Right, let's give that a bit of a clean off with some eye clear. Right, I'm just going to put a bit of flux on those pads I think first. Right, let's solder this up then. I'm just going to check I've got that straight. Not quite. That's better. Right, let's spin it around and we'll do the other one. And we can't solder this one because there's no pad. Alright, I'm happy with that. I'll just give that a little bit of a clean up. Right, let's get the test meter and we'll give it a test. So these are the two contacts that we need to test. Yeah, well, it seems to work. I don't know if I can get the test meter leads on. I haven't got the leads quite on there. There we go. Right, so that appears to be working now. Right, so I'll just put it back together and then we shall return it. Right, let's put this back together then. Right, now unfortunately I can't test it, but I'll get some feedback off the guy and find out if it works okay or not. The owner of the Dacia just came with the car so we can try the key fob. Just want to press the button, Steve, see if it works?
Thanks, Mike, let's give it a go. Oh,
yes.
look at that.
And try the other button then, just to make sure that both work.
Yeah.
Yes, great, nice one.
Thank you very much.
No problem. A Milwaukee circular saw. This is a Milwaukee CCS55 and it belongs to one of the local farmers. And he asked me could I have a look at it. Let's put the battery in, we'll see what it does. Oh, actually did something there. Let's try that again. That seems a bit odd. Right, well it's not working correctly, so let's take it apart and have a look, see if we can figure out what's wrong with it. So, it's been a while since I've looked at one of these, so I think the first thing we're going to do is remove this little handle. And then I'll remove this little handle thing here. And now I think it's just the screws around the outside here. Right, that should be all the screws removed, I think. Right, there we go. We're into it. So I've looked at a couple of these before, and a common failure is the MOSFETs on the brushless motor here. And I have had on occasion where when the brake I think's kicked in, it's backfed power when the MOSFET's shorted and fried the little microcontroller that's underneath here in this sort of silicon. I don't know whether this one's actually, this one feels hard. I don't think this one is silicon, I think it's more like a potted resin on this one. So or it could always be the switch, but let's have a look, see if we can figure out what's going on. Now, let's get this little bit out of the way for now, and we'll see if we can put a battery on this. Right, so and now it doesn't want to do anything apart from the lights lighting up. So that's a bit odd. Let's try that again. Right, let's check this switch first, just in case. So I'll just go into resistance. So there's two parts to this switch. Well, I might just be the switch on this. Let's double check my meter's working okay. I'm sure it goes from there to there. Well, that doesn't appear to be doing anything. Let's try across these contacts. Right, so that one's working. But it doesn't appear that we're getting any continuity between these two contacts here. And I'm sure those are supposed to. Let's just try from here to here, just in case. Right, I've got another one of these switches somewhere. Just want to double check that I'm actually measuring this right. Right, so I've got another one of those switches here. Let's just compare with this one. So if I go on those two contacts and press the trigger on this switch, it's a bit easier said than done. There we go. We're getting continuity there. Let's just try those other two contacts. Even though we only get about 120 ohms on this one. So anyway, I think the problem's in this switch. Let's try those top ones again. Yeah, I'm not getting that reading on that switch. So let's see if we can take this switch apart and we'll have a look inside, see what's going on. Right, let's grab a Phillips screwdriver. Right, so let's get this bit out of the way. And let's zoom down a bit on this switch. Then we'll get this diode out of the way as well. I'm just going to grab a little screwdriver just so I can see if I can get this switch apart. I don't think I've had one where it's been the switch before. It's normally been things like MOSFETs or the main microcontrollers gone on these. And one of the other sides clicked back in. Let's just zoom down a bit on that. So this looks like the problem here. It looks like this contact has gone a bit dirty and it's been arcing. So what we should be to do is to remove this, and I'll use a bit of paper and some contact cleaner, and we should be able to rub this on some paper and it should clean those up rather nicely, I think. Right, I'm just going to get sort of just a bit of paper here. I'm just going to spray it with some contact cleaner. Zoom out a fraction. Right, I'll get this contact. Look at that. Just give it a little bit more. Oh, that's a lot better. Let's do the same on the other contact. And again, that's a lot better, isn't it? Right, let's have a look at the contacts in here. Well, these may be a bit more difficult to clean because you can't actually remove them from the plastic because they're set into the plastic and sort of crimped. So I think I'm going to have to use a cotton bud maybe and some switch cleaner or contact cleaner on those. I think that's the best I'm going to be able to do with those. I think I've got one of those little, I think it's a wire, little miniature wire brush thing. I might try that just to see if that does anything. Let's grab that a second. Let's just try these bottom two. And I've still got a couple of little marks on there. I'm just wondering if there's something else I could use. I'm trying to think of any sandpaper or something just to try and clean that a bit more. About the end of a screwdriver. Let's see if we can figure out how this switch goes back together now. So we've got this spring part, and I assume that must go into here. Right, well that seems to feel okay. Let's just zoom out a bit. We'll just get the meter on and we'll try it. Just get the meter on shot. Let's try the two contacts. Right, well that looks better. Right, I'll just get this rest of this saw and we'll give it a try. Right, just try the battery and we'll see what it does now. Because it may have other problems, but we'll give it a go. And it still doesn't work. Well, we've got full battery. Oh. Yeah, I thought that one was just for the light. You don't actually need that switch there to actually make it operate. Let's just have a look at these battery contacts. I mean, the battery contacts look okay as well. Just wondered why it didn't work there the first time. I'm just going to give these a bit of a clean up with some contact cleaner as well, just in case. Let's just give that a go again. I didn't break there. This is supposed to break as well. I think there's another issue on this. See, it's breaking there now. When I let go of the switch. I'm just having a feel on this little microcontroller just to see if it's getting warm. I'm going to have a look at the motor just in case, because I wonder if there's, I don't know, a bad connection on one of the MOSFETs maybe, or one of the Hall effect sensors, because it still doesn't seem quite right to me, and I don't know why. It just doesn't seem to be firing up like it should, and sometimes, like I said, it wasn't breaking as well. Well, it's working okay there now. Right, how did this come off again? It's been a while since I've looked at one. I think you've got to take the blade off, and I think there were some screws under here to get the motor assembly off. That's another 4 screws on there, isn't there? Right, let's put this case into one side. Nice, I'll get rid of this bit as well. I'll pull the rotor out. There we go. Right, let's have a look at these Hall effect sensors down here. See what they look like. So you can see the 3 Hall effect sensors down here. One there, and one there. They're used to determine the position of the rotor, so it knows when to fire these coils. Let's have a look at the MOSFETs on the back. Well, I can't see any exploded or cracked ones. We'll quickly test those with the test meter just to see. So remember, these have got like a conformal coating on them, so sometimes it's a bit of a pain. Just going to give this a bit of a clean with a bit of brush. Right, I'm just going to give this a quick vacuum up, because I've got stuff all over my mat at the moment. Right, so let's check these MOSFETs for shorts. I'll just go on the gate pins as well, just to see. Oh, I don't have any shorted MOSFETs. And the Hall effect sensors look okay. So if there are any issues with this, it's going to be in here, which is probably going to be pretty unrepairable, seeing as it's coated in resin. And I've had one of these apart before. The only thing that's really in here is a microcontroller. Unfortunately, it's a custom part. It's an integrated motor controller and microcontroller made by Texas Instruments, and they're not available to the public, so you can't just order one off Farnell or whatever, or any of the other suppliers. And even if you could, we wouldn't have the firmware to program into it. So I mean, I've thought about designing my own little replacement board here with just a standard microcontroller, because I think it would be a useful thing to have at some point, because Milwaukee won't actually sell you a replacement microcontroller or even this part, even though it just plugs in with this ribbon cable. You've actually got to buy the whole motor assembly, which is often the price of, or near enough the price of a new saw, so it's not economical to repair them. But right, let's get this back together then, and we'll see what happens. We'll try it on a piece of wood or something. We'll give it like a real world test, and we'll see how we get on. Zoom out a fraction, we'll get this bit back in shot. Right, so that's the motor assembly back together. This little earth wire. Just over on here. Let's feed the little LED connector through. Right, so that's pretty much it. Just needs the cover put back on now. Right, so that's all the screws back in. I'll put the blade back on. Let's just pop the battery back in. Right, let's try it over the workshop and we'll see if we can cut some wood with it. Right, let's see if this works then. It actually seems to work fine. Oh well. Right then, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.